Okay, so 12 needs to be the number in the front. And so how do you decide if it's B or if it's C?
Well, I mean, if it's a 3, it's not going to be the third turn, you know?
Okay,
It'd be
so
like the 15th, you know? Like,
we want to get,
gives you a hint.
well, the right answer, if you put 1 in for the N, it should give you this first term, 15. So if it's the actual formula that gives you the nth term, if you put 1 in, it gives you 15. If you put 2 in, it gives you 27. Sorry. If you put 3 in, it gives you 39. So I took the first choice and I put 1 in for n, multiplied it by 12, added 3, it got 15. So that means that is the answer choice.
How was I supposed to know that?
Well, we learned that. Sequences and series? We did.
The third one we did.
We can use the same ideas to do the third one. Okay, so what are we adding each time on the third one?
45.
Nope. It's okay. 50 cents or 0.5. I don't even know if it's money. We're adding 0.5. So that means 0.5 should be in front of x. All right, there's only one choice that's the case. Now, if there had been two choices where that 0.5 was in front of x, you could plug in numbers. Now, this is without a calculator, so the easiest number to plug in is 0. If we put 0 in there, it'd give you the 1.25. So definitely C. All right, let's look at number 4. Now, I will admit, I did not teach you all about properties because I don't think they're important for what you need to learn in this class. But if you look at this first one and compare it to this, what happened? Like, what did somebody do to get? What'd you do? Multiplied what? To get from this to this, you added 7. So which property do you think that is? A, because you added. Adding something to both sides is the addition property of equality. All right, let's look at the next one. This one is kind of tough. So we want to know which one of these choices you can raise to the 5th power and have it equal to 2. Now, these fractions, when you raise them to the 5th power, you're just going to get other fractions. So I know it's not going to be A or B. So let's just try choice C. Now, we talked about these rules for exponents. You may or may not remember the rules. But when you have a power raised to a power, what do you do with them? They cancel because you multiply. Good. You multiply those together, it basically gives you 2 to the 1st power or just 2. So that is the answer choice. Do you all know what it means to raise something to the 1/5? This is going to come up pretty soon. Yes.
What if they're different numbers? Like
Then you would just multiply them. So or are you saying like if it was like 4 to the 5th or something like that?
No, like 1 over 4.
Then that would be 2 to the 5/4. You multiply those together. So do you guys know what it means to raise something to the 1/5 or the 1/2 or the 1/3? Anybody? It's a type of root. So anytime you have something raised to a fraction, so x to the 1/2 is the square root of x. X to the 1/3 is the cube root of x. So then when we have, well, that's fine. We'll talk some more about that in a second. All right, let's look at number 6. Now on these where you can use the calculator, if you completely blank out, you can always just plug in the answer choices and see what gives you a true statement. You can also do this on the ones without a calculator. It's not super hard. So I'm going to show you 2 ways. So if you were going to actually just solve it, what would you do to get rid of a square root? Square both sides. Good. So squaring a square root cancels it out. Now you will need to know what 9 squared is without a calculator. 9 times 9 is 81. And then you would add that 4. So that's the answer. Now, if you just were like, I don't know, my brain is fried, you can take the answer choices. Now, that it is going to be tricky, but plug it in. The square root of 3 is not 9, so it's not that one. Plug in 10. When you plug in 85, you get the square root of 81 is 9, which is true. So either way, a lot of times on the calculator ones, it's not super hard to plug in. Like just being able to add and subtract and stuff.
I just think we're not actually.
You think what?
I don't think.
I definitely taught you how to solve radical equations.
I just don't understand why they expect us to remember.
Well, we're going to review it. You're going to remember it. It's going to be fine. If not, you're going to plug in the answer choices. But yeah, the multiple select are tough. You can pick up to 5. There's probably never going to be 5 answers. But if we want to solve this x cubed equals 27, what do you guys think you would do to get rid of a cube?
Cube the other side.
Cube root the other side. Okay. And then do you know what the cube root of 27 is? What times itself 3 times gives you 27? 3. So that is definitely a choice. However, it is not the only choice. B and E. Good. So E is basically what we wrote right here. So if you showed your work, you can see E immediately. And then, like we just said a second ago, raising something to the 1/3 means it's the cube root of 27. So those are all the same. Okay. All right, we're about halfway through. So let's look at 8. We have 3 numbers represented as A, B, and C. And what our directions are is to take A, which is 2I plus 3, subtract B from it, and subtract C from it. So the first thing I would do on these ones after the minus sign, I would distribute the negative. Hey, Isaac. Okay, so now it's just a matter of combining like terms. So we have 2I minus I plus 3I. So 2I minus 1I is 1I, plus 3I is 4I. Right, and then we have 3 plus 1 minus 2. So 3 plus 1 is 4, minus 2 is 2. It's going to be C. All right. Now 9 takes what we were talking about with this fractional exponent, meaning a type of root, a little bit further. Let me get there. Okay, so we have it as a radical, and we want to write it with an exponent. And so this 8x is going to be raised to a power. And because it's a root, that power is going to be a fraction. And so we have 2 numbers we have to put into our fraction. Which one of those numbers do you think is going to go on the top? 2. And then the type of root goes on the bottom. Very good. So that looks like D. All right, number 10, we just learned last week. Yes, we did. You actually don't really need this. X is not equal to -3. to do the problem. So that's just extra stuff saying 0 is not going to be in the denominator, but it's fine. You don't need that. So what we're going to do is factor the numerator first. Since there's 4 terms, you guys remember what the method is called that we use to factor? Grouping. Okay, so I'm going to just come over to the side and factor it. It's not a ton of room here. All right, so we divide it into 2 groups. And then you're going to factor a common factor out of each group. So the first group, the common factor is 9x squared. And then when you factor that out, you divide each thing by 9x squared. It should leave you with x plus 2. All right, and then whatever sign is here is always going to come after the minus sign. So if it's a minus, you always have to factor out a negative. And then what do you put there if there is no common factor? A 1. Okay. So we are going to factor out negative 1. All right, and that's also going to leave you with x plus 2. Now for this to work, factoring by grouping to work, those 2 things have to be exactly the same, and they are. So what you factored out is in one set of parentheses, and what was left over is in the other. Now it's possible you did all that right, but then you still didn't get the right answer because we're not done factoring. Now what we're going to do in a second is whatever we get that in factored form is going to go on the top of this fraction, and 3x plus 1 is going to go on the bottom. And probably something is going to cancel out. But right now, nothing would. So we can factor one more time. Because this right here, I know we don't have a ton of room, that is the difference of squares. All right, so on difference of squares, we're going to find each square root, and we're going to put one with a plus, and we're going to put one with a minus. So 3x plus 1 and 3x minus 1. All right, so we'll stick all that on the numerator. All right, so this is when, remember the day we talked about marriage, where they live together and they die together? Do you guys see anything that has to die? Anything have to die? 3x plus 1. So if there's another couple just like them on the other side, they have to die. And then you can look at what's left. Now be careful because the answer choices are so similar, it's really easy to pick the wrong answer, but the right answer is B. Now, number 11 is an equivalent expressions question, and whoever writes the EOC test really likes equivalent expressions. I'm not a super big fan of these problems. They're hard to get right, especially without a calculator. Now, with a calculator, they're easy to get right, and we'll talk about that when we get to the calculator versions of these tests. But here, we're just going to straight have to factor this. And so the first thing we're going to do is just look for a common factor. So looking at the numbers, what's the common factor with the numbers? Good, 3. And then, like you said, they all do have an x. And when they all have an x, you're going to pick the smallest exponent to factor out. So we're going to factor out 3x to the third. And that's like the reverse of the distributive property. So we're going to divide each of those by it. And we'll be left with x squared minus 2xy plus y squared. Because this last one, this whole 3x cubed cancels out because that's what you factored out. Do you see that as one of the answer choices? Yeah, so that is an equivalent expression. It's not the only one, but it's one. So like if it was me and I was doing these problems, like every time I did a step with factoring, I would look for the result and then circle it. Okay, now this is going to factor some more. So we're just going to factor normally, where what we put here and here needs to give us x squared. So that's going to be x and x. This sign right here tells us our signs are the same. They're both going to be minuses. And then what do you guys think will multiply to give you y squared? Y and y. Good. Do you see that anywhere? Yeah, that's E. Is it somewhere else? Maybe written in a different way.
Yes.
It's A. Good. So those are all equivalent expressions. They all are equal to the same thing, just written in a different way. You'll definitely see some of those on the EOC. They love them. Okay. Now 12 is a question that if you had a calculator, if you want to know if something is equal to 0, that means when you plugged it in, you get 0. So 0 gives you 0 when you plug it in. Now that's kind of tedious without a calculator. So what we did without a calculator is something that involves synthetic division. And I'm going to remind you about synthetic division. It'll come up again. But we do synthetic division and the remainder will be 0. Now it gives you this information that 4 is a 0. We don't really need that to answer this question. So what I'm going to do is just take this first choice, the choice of -3, and I'm going to put it in the box. Then I'm going to look at my y equals, and I'm going to write all the coefficients and the constant to the right. So 1, 5, -2, -24. Okay. Now I don't really expect you guys to remember this in like today, but hopefully after we practice it some, you will. All right, now the first thing we're going to do is bring down the 1 underneath the line. And then we're going to multiply the number in the box by the number under the line. And what are we going to get? -3. And then you're going to add. So it's just multiply, add, multiply, add, multiply, add. So what about, what do you get when you add? 2. So 5 plus -3 is the same as 5 minus 3. All right, and then we're going to multiply. -3 times 2 is going to be -6. All right, then when you add, you actually add the numbers and keep the sign. All right, and then one more time. -3 times -8. A negative times a negative is a positive, 24. And we get a remainder of 0. If you get a remainder of 0, then it is a 0. Okay. Let's look at 3 more. So on number 13, the graph of this exponential function is shown. And then we do have a horizontal, the horizontal axis is time. And then the question is, what quantity could be the vertical axis? So could this graph represent the height of a growing tree? No, because this is dropping. A growing tree is never going to get shorter. So that would be no. All right, B has potential. So the speed of a car as it coasts to a stop. Could it possibly? Why not? You're right. I'm going to come back to it, though. I'm going to say it's a possibility. All right, and then C, the temperature of a cup of boiling water sitting in room temperature. So would the boiling water temperature drop? Yes. So that's a possibility. And then D, the temperature of an ice cube sitting at room temperature. The temperature of an ice cube would go up. So yeah, that's not. So we have to decide between B and C. Nolan already knows what it is. Exactly. So B, I kind of had to think about this one for a second when I was deciding between B and C. If the car stopped, then the speed would go all the way to 0. And like he said, it doesn't go to 0. It flattens out higher. So we're going to say it doesn't get to 0. So it can't be B. It's the boiling water. And the boiling water would stop at room temperature. And room temperature could be anything. 76 degrees. It's going to be hopefully above 0 degrees in any room I'm in. All right, a couple more. So this one, the population of deer on an island is given by that function where x represents the number of years. Determine if the rate of change for the population, determine the percent rate of change for the population of deer per year. So that all has to do with this 0.85. If that number, the number that's the base is less than 1, it's decreasing. So I can decide between A and B. Now, this is actual depreciation. Now, I'm going to have to look at your reference sheet. I meant to before this class, and I forgot. I know there are some formulas about exponential growth on there. I'm not sure if this one is. I'll let you know tomorrow for sure. But the formula for depreciation is something like this. And R is going to be the rate that is decreasing. So which one of those rates do you think it is for us to do 1 minus it to get 0.85? 85% or 15%? So R is going to be 0.15 to get 85.8.
All the ones that I guessed on are right. All the ones I tried on are wrong.
That's weird. You're a good guesser, I guess. Okay, this last one uses I. Do you guys remember what I is equal to? Or I squared, what I squared is equal to? I squared is -1. I is the square root of -1. That's going to come, the I squared is going to come in handy on this problem. Okay, so what I'm going to do first is just multiply this out. So I'm going to do 3x times 3x. 3x times -2i. Okay, and then I'll distribute the 2i. Okay, so what about this -6ix and +6ix? What's going to happen with those? These middle terms, what's going to happen? What do they equal? 0. So they're going to subtract away. And then we have 9x squared. And then do you guys remember what -4i squared is? Somebody did remember this fourth period. I was pretty pumped. -4i squared is just 4. Because I squared is -1. So the I squared just changes the sign of the number in front of it and disappears. So the answer is B. All right, now I'm going to go back on the video to the first question. Yay! To the first question because I started the video late.